Okay. Arithmetic sequences. Arithmetic means you add the same thing each time. And then a sequence it's just a sequence of numbers. A series is when they're being added up. Geometric is when it's times something each time. So, excuse me, GCSE, you've got y equals mx plus c. For a sequence of numbers, you might say nth term is dn plus c, like common difference, and then plus c. A level, it's the same thing. They just write it this way. A plus n minus 1d. So d is the common difference, and a is the first term.
Okay.
Let's see. Okay. How about this one? Yep. Ouch.
So I want the first 5 terms of the sequence. Do I need to sub in like 1, 2, 3, 4, 5, or?
Yep. And do you know a quick way to do it with your calculator?
No.
Let me show you. And I want to try using the graphical one for this one. Simple calculator would be menu, table, and then use table of values. I think table is option 9. Graphical calculator, which I'm less familiar with. Table is 7. Okay, so menu 7 for table. Okay, and then do 55 minus 2x, I think. 55 minus 2x. Will that work? Press equals or F6 for table. Ooh, this is weird. Hang on. Let's see. Exit. Type should be fine. Set F5, is it? Yes. So F5 to set the parameters. So start from 1, stop at 5, and go up in steps of 1 each time. And there we go. 53, 51, 49, 47, and 45. Ooh, it even does a graph as well if you press equal, if you press enter again. Okay. Oh, I have to press exit, I think. There we go. Okay. Any questions about that?
So what you did, you went to the table function bit, then you typed in 55 minus 2x, and then is that how it gave you the answers, or?
Yep. 55 minus 2x, and
Yeah.
then press equals or F6 for table. I had to go to F5 set first.
Okay.
And start at 1, stop at 5, because we wanted the first 5 terms.
Yeah.
And go up in steps of 1. But you could change those to whatever the question needed.
And so I need to get an x and a y1 as my two answers, right? Or
No, I think the calculator is giving this like a derivative or something. This y-1, I think that's the derivative.
it didn't give me the y dash one, but it gave me the other numbers. So,
Oh, okay. Yeah. So, okay. So what are the first 5 terms for this sequence?
53, 51, 49, 47, 45.
Yep. Okay. How do we do B?
Would be sub in 99.
Yep.
So would that just be 55 minus 2 times 99?
Yep.
And I got minus 143.
Minus 100. Whoops. 43. And then how would you do C?
I could be really boring and go down the entire graph, but
That'll work. And believe it or not, I was looking at the video for that the book has, and that's the way the book did it. A much better way is 55 minus 2n. If it's negative, it's less than 0.
okay.
And you'd solve that.
Should I see the term?
Yeah.
It's the 28th term.
I don't know. Let's see. Minus 2n less than 55. So 2n greater than, whoops, positive 55. Half of 54, 27.5. And so, yeah, it has to be greater than 27 and a half. And so it's term 28.
Okay.
So I think that's what you said, isn't it?
Yeah, yeah.
Yeah. And just as a little extra thing, I just wanted to see if this would work, and it did. You don't have to do this. 55 minus 2x. I just set it as start at 99 and end at 99. And then I got minus 143, which was the same as doing the other way. But just because I had it handy in the calculator. I think your way is better. Just 55 minus 2 times 99. Any questions there?
No.
Okay, I took these from the videos. I forgot about that. Let's see. Let us see. Are any of these worth doing? The value common difference. Let's see if they get any harder. I suppose we should. Hang on. I will just do one of these. What's that? One. Let's do this one. The first 4 terms for that sequence.
Okay, so yeah. I got so for the first 4 terms I got 8.5, 9.5, 10.
9.5 and 10. Yep. And for that one, what is A? What is D?
Is a 8.5.
A is the first term. Wait, yeah. So A is 8.5. And D?
Is D a half?
Yep.
Okay.
That's great. So that is 1. See, and I suppose, so what is the nth term for that sequence?
8 plus half n.
I believe it is 8 plus n minus 1 a half.
Okay.
Yeah, A plus n minus 1 D. Let me just go back. Did they say that's equal to un? Un, yeah, equals A plus n minus 1 D. Okay. That is nth term, un. That was C. Is that the right question? There we go. 8.5, 9, 9.5, 10. A is 8.5, D is 0.5. Great. Okay, nth term for these sequences.
Okay, so would it be something like 14n plus 4?
For the first one?
Yeah.
No, you're right. 14 and plus 4.
I need to write that a different way, don't I?
You don't have to. It's just so let's say un is equal to okay, that's fine. So 6 plus n minus 1, and the common difference is 14. Do they end up being the same thing? 14n, yes. Minus 14 plus 6, I think no. Aha, how did you get plus 4?
I shouldn't have got plus 4, I don't think. I should have got like a -8.
Yeah, that's it. You did, I think you did -4, but you should have minus 14. Is that it?
Yeah.
Yeah, okay. So yeah, this is kind of GCSE way. This is A-level way. Both are exactly the same. Maybe I should teach this A-level way at GCSE.
Okay.
That's what I'm thinking. Oh, don't listen to me. Why would they do this to me? So 14n minus 8 is kind of the most, it's the most simplified way. And then this is the, why do you do this to me, bookie? Okay, let's see. So a bunch of weird questions in here. I don't want to do that unless it's an exam question. Okay, let's try these. Yep.
Okay. So do I need to do something like 32 minus 14 divided by 4?
Did you say 18?
No, do I need to do like 32 minus 14 divided by 4? Oh, yeah, sorry. 8. I need to do
Okay. Uh,
8. Yeah, would I need to do, sorry,
go on, try it.
18 divided by 4, yeah. And it gave me 4.5.
Let's see. The first term in arithmetic sequence is 14. The fourth term is 32. 1, 3, 4, 32. I think you'd have to divide it by 3. So if you were like times by common difference each time, oh, it's not times, it's plus. Sorry, plus common difference each time. And in fact, let's just see. So this is going to be here 14 plus D. What will be the next one?
14 plus 2D.
That's 14 plus 2D. And so what about 32?
14 plus 3D.
And so that means that 14 plus 3 times common difference gives you 32. And so you'd have to do, 3D is equal to 18. So it's divided by 3 because we don't include the first term. So it'd be like second, third, fourth. Yes. So it's 18 divided by 3.
So, 6. And then, so would the missing terms be like 20, 26?
Yeah. And they wanted, they just wanted the common difference. Okay. Yes. So if I thought it would be, it seemed like it might be 4 because it's the fourth term, but we don't include the first term because there's 1, 2, 3 jumps. Okay. Next one.
Okay, so here would I need to do something like 4 plus 5D equals to, oh no, so would I need to do something like 17 plus 5D equals to 47?
47. Yep.
And then, so is the common difference 6 again?
Oh, is it? I don't know. Is this one though 6D? Well, we'll see. Do I have the answers? This one is saying the common difference is 5. I think it might be. Why is that? So you have, let's see, 1, 2, 3. The fourth term is 17. 5, 6, 7, 8, 9, and then 47. And so you have 17 plus D. So that's, 1, 2, 3, 4, 5, 6. So that is 17 plus 6D is 47. So you're dividing by 6.
Yeah.
So what would you get for that one?
Yeah, I got common difference is 5.
And what is first term? It says find the first term.
So would the first term be like 17 minus 3D?
Yep.
So would that be 2?
3D is equal to 2. Yep. So we could probably make a formula for this, but I just find it easier to write it out like that. Yeah, that's weird. So with this one, we had to, hang on, that was 1, 2, 3. So I had to do 3Ds. But this one, there was 1, 2, 3. There just was. All right. Any questions there?
No.
It's just weird how this was 3 and then this one is 6.
Yeah.
Anyway, all right. A sequence is generated by this formula. All right, let's try this one.
So are they basically saying that the third term of the sequence is 5 and the eighth is 8?
Yeah.
And so would I then need to do like so would I need to find the difference of 5 and 20?
Yep.
Which is 15.
Mm-hmm.
And also there's 4 terms missing, I think, from in between those two.
Okay.
Do I do like 15 divided by 4?
I think it'd be divided by 5.
Okay.
So what do you get there?
3.
Yeah. And what's next?
I need to find the first term.
Mm-hmm.
And so I think that would be -1.
Mm-hmm. And so they kind of used different letters. They just used A and B. So which is which for this one?
So it goes something like UN equals to -n plus 3.
I don't think so. So I think like if we just did A plus N minus 1D and we subbed into that N minus 1 times 3. So what would this be?
That would be -1 plus 3n minus 3. So -4 plus 3n.
Yeah, 3n minus 4. And so what is A? What is B?
A is 3 and B is -4.
Yeah, it's a bit confusing that they used A and B when A usually means the first term. Here, their A is D, the common difference.
Yeah.
The number in front of N, so that's weird. They should have used like P and Q or something. What else was I gonna say here? So this was a difference of 5. U8 take away U3 is 5 things. I think it was just that the first one was special because it started from 1. Let me just go back. Oh, where'd it go? I think this was special because it started from 1, and then every other one works the way you would expect. Let me just check this one. So that had a 1. No, that should have worked. Fourth term, take away first term is 3. So that's why we're dividing that by 3. Yeah, it always works. So it's always going to be later term minus earlier term divided by the difference between them. So 4 minus 1 is 3. Yeah, it just felt special because it was starting from 1. But
Yeah.
it actually follows the same pattern. Let's see. Okay, let's try question 5. You see, they made it. This is a later version of the same book, and they used P and Q. So yeah, they learned that lesson. Okay, so what would be question 5 up the top?
So, so the difference between 9 and 11 is 2.
Yep.
And so, would I need to do something like 2 divided by 3? Or
Yep. Nothing wrong with that. 2/3.
And then sub in. And then would I need to do like 9 minus 6 times 2/3 to get the first stop?
Let me see. What did we do the last time? The last one. So we were at U3. We had to times it by 2 because U3, U2, U1. Yeah, we did. What was this one? Yes. So instead of, so it's not minus 2/3 times 6. I think it's minus U 2/3 times 5 to get back to U1.
Okay. So that would be 17 over 3.
Yeah. Hopefully that's right. Okay. And they wanted P and Q.
So would that be UN equals to 17/3 PN plus 2/3?
Let's see. Thirds and so let's use this one. A plus N minus 1D.
Okay. So is it equals to 17/3 plus N minus 1 2/3?
2/3. Yep. And then go from there.
And so that would be 17 over 3 minus 2/3 plus 2/3 N.
Yeah.
And so it gives me 2/3 N plus 5.
Mm-hmm. So P equals Q equals?
P equals to 2/3, Q equals to 5.
Looks good. 5, 2/3, and 5. Yep. Any questions here?
No.
Okay. I'm going to exam questions. Hang on, this is an exam question. Let's try this.
Okay. So would I then do, so the difference between minus 22 and minus 2 is 20.
Mm-hmm.
And then would I then do 20 divided by 5?
4th, 9th, yep.
And so I would get equals to 4.
Yes. However, you gave me the absolute difference between them is 20. You'll notice that the later term is more negative than the earlier term.
So
Or what would you get if you put minus 22 minus minus 2 into your calculator?
Minus 20.
Yeah. So you get minus 4 in the end.
And so would I then need to do like so minus 4 times 3 plus minus 2 equal no minus 2 equals to the first term, or
Okay, go on, say it again, sorry.
so would I then do minus 2 minus minus 4 times 3.
Well done. And a lot of minuses there. I would just put it in your calculator.
Yeah. And I got 10.
So I'm just going to trust that.
And so what I then need to do like un equals to 10 and then n minus 1 minus 4.
Yeah.
And that would give me 10 minus 4n plus.
True. You weren't asked for that.
Okay.
Just what is A, what is D?
A is minus 4, D is 10. Oh, no, sorry, other way around. A
Yeah.
is 10, D is minus 4.
Yeah. And part B.
Find value then. So would I need to sub in like minus 2 equals to
Minus 2 was the fourth term.
yeah.
Imagine it's okay. Imagine they said the xth term is 50 minus 54. Find x.
I'm not sure.
Basically, there will be, so for this one down here, un equals 10 plus n minus 1 minus 4. And just for the sake of clarity, I'll just put times minus 4. Times minus 4, so just so we don't make any mistakes. If you were to sub 4 for n, you would get minus 2. If you were to sub 9 for n, you would get minus 22. We want to know what term you'd sub in for n and get minus 54.
Oh, right. So would I just do like minus 54 equals to 10 plus and minus 1 times minus 4 and put into my calculator?
Yep, great.
Okay.
54. I want to do the same thing.
I got that n is 17.
N equals 17. N equals 17. So that's basically the 17th term. You have 10 minutes at the end of your exam. How would you check your answer?
Sub 17 into the 10 plus n minus 1 times minus 4.
And if you're correct, what answer should you get?
Minus 54.
Yeah. Okay. Let's just check this one. A is 10, D is minus 4, and that one is N is 17. Great. Any questions there?
No.
Okay. Let's see this one. Oh, wow. All right. Any idea how you do question 9?
So something like so would I need to do something like k squared equals to minus 8 plus d, and 17k is equals to minus 8 plus 2d.
Yeah, say the second one again, sorry.
Minus 8 plus 2d equals to 17k.
Is equal to 17k. Yep. What could you do next?
And then could I just do like a simultaneous equation?
Yeah, you've got
So
a quadratic.
could I do something like d is equals to k squared plus 8?
Yep.
And then if I do minus 8 times 2, no, plus 2k squared plus 8 equals to 17k,
Mm-hmm.
I would get minus 8 plus 2k squared plus 16.
Mm-hmm.
And then I would get, so 2k squared plus 8. Oh no, sorry, 2k squared minus 17k plus 8. And I'll just put that into my calculator.
Yeah. Go on. I might as well finish it. Oops.
I got that k is 8 or k is a half.
You're too quick for me. K equals 8 or k equals a half. K equals a half or k equals 8. Let's take a look at this one and put these on the same page because they're similar. The first three terms are that. Find the two possible values of p. So they're actually kind of identical. What is part A though? A, B and C are three consecutive terms in an arithmetic sequence. Show that A plus B over 2, A plus C over 2 is equal to B. Alright, how do you do part A?
Would you just put in like real numbers?
That might help, but we have to do it algebraically.
So would I need to do something like a? Okay, so would I do b is equals to a plus b is equals to a plus d,
Right.
and c is equals to a plus 2d.
Right.
And so but I need to do a simultaneous equation here again now.
Yeah.
So but I do like b minus d equals to a, or even sorry, b minus a equals to d,
Yeah.
and then do c is equals to a plus 2 times b minus a, and then that would give 2b minus 2a. So would it be like minus a plus 2b?
Yeah. So you want to make it B equals?
So would I do a plus d equals to, oh sorry, a plus d,
There's no D.
oh sorry, c
Yeah.
over 2 equals b.
Yeah. So that's equal to 2B. And so A plus C over 2 is equal to B. So to show that question, so I just did every step. Okay, so you just did it, same thing you did before, but with pure algebra. And actually pretty interesting. I never knew that. So let's see. So that's that's A, B, and C. So that's just in general. Any arithmetic sequence, the first term plus the third term divided by 2 gives you the second term. I did not know that. Okay, any questions there?
No.
That's good. So they're just doing it. They did that as part A, and that's supposed to help you with part B. So we could have just gone straight from, let's see, minus 8 plus 17k over 2 gives you k squared. All right, I probably won't remember that. Probably just do it the long way. Okay, find the value of k, find the value of the 50th term. I think you're okay for that. So that's very similar. An arithmetic sequence has first term k squared, common difference k. All right, let's do question 10.
Okay. Would I do something like k squared plus 4k equals to 41?
K squared plus what, sorry?
4k equals to 41.
41.
And then k squared plus 4k minus 41 equals 0.
Yeah. Find the value. Okay.
And then I got minus 2 plus 3 root 5, or minus 2 minus 3 root 5.
Okay. 3 root 5. And it says k is greater than 0.
So would it just be minus 2 plus 3 root 5?
Yeah. What is p? Nah, you did it. It's fine. Okay, that was easier than I thought it would be. It looked weird. Okay, arithmetic sequences.
I'll give it a tick.
Yeah, that's all right. Okay, we did the weird stuff. Those were sequences. We're now going to do arithmetic series. That's when you have instead of a comma in between them, you have a plus in between them. So it's being added up. So you don't just want like what are the first terms. You actually want what is the sum of the first four terms. Okay, so first there's this proving thing. It's probably going to be easier to just memorize this, but there is a way to do it. So I don't expect you to know this method. Some smart man, Galois or someone came up with this. Euler or someone when he was a schoolboy. Crazy stuff. Prove that the sum of the first 100 natural numbers is 50-50. What that means is 1 plus 2 plus 3 plus ... 98 plus 99 plus 100 gives you 50-50. And you have to prove that that's true. So sum first 100 natural numbers. How do we do this? The trick is to add the first and last. Second plus second last. Third plus third last. And so on. You get 101. 101, 101. How many 101s will you get?
50.
Yeah. And so 101 times by 50, and I think that's 50-50. I think that's it. Let's see. Yeah, that's how it works. Let's see. How did they do this thing? Adding 1 and 2. Yeah, they did the same thing. So any questions about that?
No.
Okay. Would you have guessed that?
Probably not.
Yeah. It's not actually the thing I thought. I thought it was. This is the one that I thought it was. This is the question that I thought they were asking. So you now have to prove that the sum of the natural numbers algebraically. What is the first term?
1.
In general, algebraically, we'll say A.
Oh, right, okay.
What is, in terms of algebra, second term?
B.
A plus D.
Oh, of course. Okay, fine.
Well, not of course. It's tricky stuff. Next one.
A plus 2D.
Yeah, a plus 2d plus dot dot dot. Um, any idea what the last term will be?
A um A plus 98D, 99D.
Uh, yes, except now they want us to do this one. So a lot of people would think it is a plus nd, but it's actually a plus n minus 1d, like you said, 99, because there's no d in the first term.
Yeah.
So d starts from the second term, so it's always one less than the n. The second last term would be a plus n minus 2d. Prove this thing. So that is the sum to n terms. You then double everything. So 2 times the sum to n terms would be 2a plus 2a plus 2d, something like that, plus 2a plus 4d. And then you do the top one, take away the bottom one. So 2 sum to n terms minus the sum to n terms give you sum to n terms is their formula there. N over 2 2a plus n minus 1 d. Let's see. Why is that? It's because if you add first and last, you would get 2a plus n minus 1d. Yeah, if you add first to last, you get 2a plus n minus 1d. That's the 2a plus n minus 1d.
Yeah.
With the first, what's that called? The first 100 terms. Remember, we got 50 because it cuts it in half.
Yeah.
And that's why you have n over 2. So instead of it being 100, it's 50. Instead of it being n, it's n over 2. So first plus last, 2a plus n minus 1d, and then times by n over 2. It's probably easier to just kind of memorize the steps for that. Let's see. They did... yeah, they did the same thing. Okay, how do we do this?
So what I need to, so I can see that it's going down by 5.
Yeah.
So the common difference is minus 5.
Yeah.
And the first term is 32.
What is n?
Um,
N stands for the number of terms.
50.
Yep. And so we produced this formula.
So would that be like 25?
Yep.
And then brackets 64 plus n minus 1
what is n?
plus 49, sorry.
Yeah.
Times minus 5.
Yeah.
And so that would give me minus 4,525.
525 minus 4,525. So these numbers, they start off positive. Eventually they're going to get negative, and first 50 terms. And so if you were to add all those together, you'd start adding on negative terms, and you end up with this minus number. So we have a formula that can add up numbers for us. Any questions there?
No.
Okay. All right, let's try this thing. .
Um, is this where I can put this into my calculator?
How would you go about it?
Would you put in like 5n minus one?
Yeah. So I want to disagree with you, but this is what the book did, or what the video did. Table function. So 5x minus 1. And I could just set this for, let's say, 1 to 20.
Yeah.
Because I don't know what it's going to be. Press equals and go down until it's bigger than 2000, was it? Till it's bigger than 2000.
Yeah.
Ooh, it's going to be a while. Oh, no. Hang on. It's because this is the sum. It's not a sequence.
Yeah. So would I need to do something like would I do the normal formula like n over two and all that stuff,
Yeah.
or
Do you remember it?
n over two plot a 2a plus n minus one brackets and then d,
Yeah.
and so would that be five? Oh no, so I've got uh I still need to get n, don't I?
Yeah, that's what we're trying to solve.
Um,
What is A?
A is five.
What is D? Wait, A isn't 5. D is
A,
5.
A is four. Sorry.
Yeah, D is 5. We want when this thing exceeds 2000.
So is it 2000 equals to?
That'll work. Yep.
So would it be like 2000 equals to n over two brackets two times four plus n brackets n minus one times five?
Mm-hmm. And you could do equals
So
2000. I'll write greater than 2000 and just use equals in the calculator.
on the calculator, is there actually a way to do like an inequality?
Only for quadratics, unfortunately.
Okay.
So for this one, I have to do x over 2. X minus 1 times 5 equals 2000. Tell me if you get an answer for this one.
I got syntax error like constantly.
You went wrong somewhere. Did you, you're using graphical, is it?
I was using just a normal calculator. I'll try again.
That's what mine looks like. Did you close the bracket, the x minus 1 in that bracket?
Yeah.
Why didn't I get syntax error? I did mine wrong, actually.
I got zero.
Hang on. Put a closed bracket after the times 5. I did mine wrong and the calculator forgave me. Yeah, we have to close the bracket after the times 5. Calculator just forgave me. Did you do... Okay. I think you...
Oh,
So just check what's different between you and mine.
Yeah, I've got the same answer as you.
Okay, and so what is the answer for this one?
Would it be 28?
Yeah, n equals 28, the 28th term. So you just sub it into the formula. It's when that gives you something that's greater than 2000. There we go. So it turns out it becomes a quadratic and you get a negative number as well. But you can't have a negative term, like term minus 1 or something. Any questions about that?
No.
Okay, let's see. So prove that the sum of the first natural numbers is this. You may not use the formula. Hang on a second. n plus 1 over 2. How would you use part A to do part B?
So first. Would I have to sub in whatever n is into
Yeah.
and some of the one?
Any idea what n would be?
Would it be 2 and 200 or?
It's the even numbers. How many even numbers are between 2 and 200?
About 99.
Yeah, I think it might be 100. Is it 100? 101 over 2? I think that's the 50-50 thing. Is that right? Or is it double 50-50? I don't know. It's double 50-50. 10. So it's 100. Let's see. So it's 10,100. Okay, so that only works if it's the even numbers. 100 times 202 over 2. That's not right. It should be 100 times 101, shouldn't it?
I'm guessing so.
Yeah. If n is 100, then it's 100 times 100 plus 1. Oh, that's a misprint. They recently emailed me back saying they're going to change the future edition because I found a misprint. That's a misprint right there. That should be 101.
Okay.
I'm sure if you put in a calculator, you get that. All right. Weird. Let's see this. An arithmetic sequence has this and this. First term A, common difference D. The sum of the first 12 terms. Sure. All right. Let's try this.
So wouldn't it be something like 12a plus 11d is equals 36, 366?
I think that would be the 12th term. This is the sum to 12 terms. So this is the sum formula.
So
So instead of it being like dn plus c, instead of it being the 12th term, it's the sum of the first 12 terms gives you 366.
If I wanted to do 366 divided by 12.
Show that you can't use what they give you. It is the sum to 12 terms. That's your sum formula. What is the sum to 12 terms?
So, would it be 12 over 2?
Yep.
And then 2a plus 12 minus 1 times d.
Yep. What is that?
And that is that all equal to 366?
Yep.
And so do I need to expand all the brackets here?
Yep.
So I would get 2a plus 12d minus d all times 12 over 2.
Yep. What is 12 over 2?
6. And then I would get 12a. So I'd get 12a plus 66d equals to 366.
Yeah. Originally, you said 12a plus 11d because
Right.
that would be the 12th term, but it's actually the sum to 12 terms. So I just use the formula and sub it in. How do we do b?
Would I just do like a plus a would I do 2a plus
This isn't a sum. This is the 8th term. So not the sum to 8 terms.
so a plus 11 over 2d.
Just 11d. Sorry, not 11. 8th term.
Oh, plus 8d.
N minus 1, 7d.
7d equals to 38.
Yeah. And then how would you go about c?
Would I have to sub that stuff into the formula?
Sub what into what?
Would I sub like 38 into the n? Oh no, sorry, 7 into the n, and then make the equation equals to 38.
You would basically have to solve these simultaneous equations. So this is 1, this is 2, and you might make this one a equals, and then sub that for a in this one and solve it.
Okay.
Tricky stuff. Hang on, let me go back, because this is a new topic. Let's see. So arithmetic sequences and arithmetic series. So sequences, you saw, dn plus c. Now they're using a plus n minus 1 d. Same idea. This stuff, you can use calculator to get the first 5 terms. A is first term, D is common difference. Let's see. 14. So yeah, those ones you're pretty good for. Finding those ones. Yeah, just get it and then just make it look like they're one, expand the brackets. So I think you're pretty good for the series. It's the sequences that are new. Let's see. That one's okay. Yeah, so a lot of the time you're just subbing the values into an equation. You're making it equal to whatever you're told it's equal to, and then you solve for that value. Then we did it algebraically. You're pretty good for that. You're very good for that, actually. I think you're really good with the stuff that's also like crossover with GCSE. Prove the sum of 100 natural terms is 50-50. So that's like first plus last, first plus last. That's where we get the formula from. And then similar idea, you sub into the formula, make it equal to whatever you're trying to find, and solve it. The difference here. It's just difficult. Yeah. All right. We'll have to continue these next time. How was that for you, Andrey?
Yeah, I was good. Thank you.
Any questions for me in general?
No, I don't think so.
All right. Well done. You did great. I look forward to chatting again next time.
Okay. Thank you. Bye.
Have a good one. Goodbye.